Hello everyone, myself Keerthana. Today I am going to present the topic Vanilla GAN and Style Transfer with GANs. This topic comes under Generative Artificial Intelligence. In this presentation, we will discuss what GAN is, how GAN works, its architecture, and how GANs are used for style transfer application. We will also see the advantages, limitation, and the future scope of GAN-based style transfer. Then we move to introduction. Generative Adversarial Network, commonly called GAN, is a deep learning model introduced by Lan Goodfellow in 2014. GAN is mainly used for generating new data that resembles existing training data. The main objective of GAN is to learn the data distribution and create realistic outputs. GANs are widely used in image generation, synthetic data creation, video generation, and many AI applications. Today, GAN is considered one of the most powerful generative AI techniques. And then why GAN? GAN is important because it can automatically generate realistic content without manual effort. Traditional machine learning models mainly focus on prediction, but GAN focus on creating new data. GANs are useful for generating human faces, artworks, animation, and realistic images. They are also used in data augmentation, image enhancement, gaming entertainment, healthcare, and creative AI application. Due to these advantages, GAN become one of the most popular generative AI models. Next, components of GAN. GAN mainly consists of two neural networks. The first network is generator. The generator creates fake samples using random input data. The second network is discriminator. The discriminator checks whether the generator data is real or fake. These two networks continuously compete with each other. The generator tries to fool the discriminator while the discriminator tries to correctly identify fake data. Because of this competition, the performance of both networks improve continuously. The next slide is working principle. The working principle of GAN follows several steps. First, random noise is given as input to the generator. Then the generator creates a fake image or fake sample. After that, the discriminator receives both real data and generated fake data. The discriminator checks whether the data is real or fake and gives feedback. Based on this feedback, the generator improves itself and tries to generate more realistic outputs. This process repeats continuously until the generated images become very close to real images. Then it's GAN architecture. This architecture shows the flow inside GAN. Random noises provide as input to the generator network. The generator converts this noise into fake data. Then the fake data and the real data are given to the discriminator. The discriminator compares both inputs and produces the output as real or fake. Based on this output, both generator and discriminator update their parameters during training. This adversarial learning process helps GAN produce high quality outputs. Next, training process. The training process starts with random noise input. The generator creates a fake samples from this noise. These fake samples are compared with real samples by the discriminator. The discriminator learns to correctly identify fake and real data. At the same time, the generator learns how to fool the discriminator. This training process repeats many times until the generator produces realistic outputs. Proper training is very important because GAN training can sometimes become unstable. And the next slide is advantages and disadvantages of GAN. GAN provides several advantages. It can generate realistic images with a high quality. GAN supports unsupervised learning, which means it does not always require labeled data. GAN is widely used in image synthesis, image enhancement, and creative AI application. However, GAN also has some disadvantages. Training GAN is difficult and unstable. It requires high computational power and expensive hardware resources. Another common problem is mode collapse, where the generator produces limited types of outputs repeatedly. Parameter tuning is also challenging in GAN models. Then, introduction to style transfer. Style transfer is a deep learning technique used to combine content from one image and style from another image. The content image provides structure, objects, and layout information. The style image provide artistic appearance such as colors, textures, and pattern. The final generated image combines both content and artistic style together. Style transfer is widely used in digital art, photo editing, and creative application. Then we move to the slide why style transfer is needed. Style transfer is needed because it helps create artistic images automatically without manual editing. It reduces editing effort and saves time. Style transfer is widely used in social media filters, entertainment industries, gaming, advertising, and image processing application. It also improves creativity and productivity in image editing tasks. Nowadays, many mobile application and AI tools use style transfer technology. Then the basic concept of style transfer. Style transfer mainly contains two important concepts. The first concept is content representation. Content representation includes objects, shapes, structure, and layout information present in the image. The second concept is style representation. Style representation includes colors, textures, brush patterns, and artistic appearance. Both content and style features are extracted separately and then combined to create the final stylized image. Then we move to the working principle of style transfer. The style transfer process begins by selecting two images, one content image and one style image. Neural networks are used to extract features from both images. The content features preserve the original structure of the image while the style features preserve the artistic appearance. These features are then combined together using optimization techniques. Finally, a new stylized image is generated that contains the content of one image and the style of another image. Then we move to the topic of neural style transfer. Neural style transfer uses deep neural networks for extracting image features. First, the network extracts content features from the content image, then it extracts style features from the style image. Optimization algorithms are applied to combine both features together. During this process, the output image gradually changes until it preserves the content while adopting the artistic style. Neural style transfer produces visually attractive and artistic outputs. Then the topic is limitation of traditional style transfer. Traditional style transfer methods have several limitations. They require high computational power and consume more processing time. These methods also require expensive hardware resources such as GPU. Another limitation is that traditional methods are not suitable for real time applications because the image generation process is slow. Due to these limitations, researchers started developing GAN based style transfer approaches for faster and better results. Then the topic is style transfer using GAN. GAN based style transfer improves both speed and output quality. In this method, the generator creates stylized images while the discriminator checks whether the generated images look realistic or not. Because of adversarial training, GAN can generate high quality stylized outputs much faster than traditional methods. GAN based approaches are widely used in real time image editing, video filters, and AI art generation systems. Then we move to GAN based style transfer architecture. This architecture combines generator and discriminator network for style transfer task. The generator receives the content image as input and produces stylized images. The discriminator evaluates the realism and quality of generated images based on discriminator feedback. The generator continuously improves its outputs. Through continuous adversarial training, the system produces high quality stylized images with better speed and performance. Then the topic is advantages and disadvantages. GAN based style transfer provides several advantages such as faster image generation, better output quality, real time processing capability, and improved scalability. It can also handle large data sets efficiently. However, GAN based style transfer also has some disadvantages. It requires high computational resources and large data sets for training. Training instability and mode collapse are still major challenges in GAN. Sometimes generated image may also contain distortions or artifacts. Then the last slide is future scope. The future scope of GAN-based style transfer is very large. Future applications include real-time video editing, advanced artistic generation, 3D image transformation, virtual reality application, personalized content creation, and AI-based art generation systems. Researchers are also working on improving output quality, reducing training costs, and developing more efficient GAN architecture. Thank you for everyone for listening to my presentation.